Previously, we had learned the integrals of the sine and the cosine. So these two we've learned already. So we learned that the antiderivative of the sine is negative cosine. The antiderivative of cosine is sine. Now we're going to learn the rules for the other four basic trig functions. I want to show you the proof for the tangent. So tangent is really sine over cosine. And really, this is, you can do 1 over u idea. Your u would be cosine of x. Your du would be negative sine of x, dx. The only thing you're missing is a negative sign, so this is really negative 1 over u du. So this ends up being negative natural log of cosine of u plus c. And we can just use the x for the u here. So that's why the antiderivative of the tangent is negative ln of cosine of u plus c. And you can use the same idea for the cotangent. The proofs for the secant and cosecant are a little bit more complicated. It's in the book if you want to read it, but we're going to just go ahead and memorize it and start using them. So the antiderivative of the secant is natural log of secant plus tangent. The antiderivative of the cosecant is negative ln of cosecant plus cotangent. Okay, so let's try to figure out what these antiderivatives are. So remember with the trig ones, if there is an antiderivative for the trig, so there is an antiderivative for the cotangent, your u has to be the angle. So your u has to be x squared. My du will be 2x dx. Notice that's why you have the x and the dx here, so I need that reciprocal in the front, and this is really cotangent of u du. So this becomes 1/2. Antiderivative cotangent is natural log of sine of u plus c, and then go ahead and substitute in your u, which is sine of x squared plus c. Okay, number 2, same idea. There is an antiderivative for tangent, so my u is going to be x over 2. My du is 1/2 dx. I am missing a 1/2, so I need to put that reciprocal of 2, tangent of u du. So this is going to become 2 natural log of cosine of u plus c. Do your substitution, cosine of x over 2 plus c. Okay, number 3, there is no antiderivative for all of this squared. So what we need to do here is simplify this a little bit. So I'm going to go ahead and multiply this out. If you multiply this out, you're going to get cosecant squared minus 2 cosecant of cosecant x plus 1. Now let's look at each of the pieces and see what we have an antiderivative for. So we do have an antiderivative for cosecant squared. It is negative cotangent. It's one of the rules that we learned way back when. There is an antiderivative for cosecant, and we know how to take the antiderivative 1, so I can just do each piece separately. So this is negative cotangent of x. This is going to become a positive 2 ln of cosecant of x minus cotangent of x. Antiderivative 1 is just x plus c. Here, this is just going back to our sine. My u is 2x. My du is 2 dx. I need that reciprocal. So this is my rewrite. Antiderivative of the sine is negative cosine. So I'm going to go ahead and substitute in that 2x right away. Okay, last one, find the average value. Remember, anytime I ask you to find the average, you should be thinking about this. In this case, 1 over b minus a will just be 1 over pi over fourths. 0 to pi fourths, the function is tangent of x. And we are going to go ahead and use your calculator, so just make sure you're in radian mode, and if you plug this in, you're going to get 0.441.